Good afternoon, everyone. My name is Julie Payette. I am the Governor General of Canada. Today, we're October 15th, 2020, and we're still in the pandemic and we're still fighting now what we call a second wave. We have to remain vigilant. We have to continue to abide by the public safety measures, and we can't let our guard down. It's all of us that will beat this virus. And today, at our GG conversation, we will talk about a fascinating subject, artificial intelligence, with a great expert. But he is also very involved in something that you might be familiar with, which is the Alert COVID application. So today, I have the distinct pleasure to welcome Jean-François Gagné, founder of Element AI. It's an enterprise that he founded a few years ago, but it's his third firm that he has founded that is looking at operational research and using techniques of artificial intelligence to serve us in our society. He is a what we call in French autodidact, self-learner, and a passionate, one of the most creative person I've ever met. I have the honor to present to you Jean-François Gagné. Bonjour. Hello, Jean-François.
Pleasure to be here, Madam Governor. It's a pleasure.
Welcome to our GG conversation. So today we're going to go and talk about AI. But before I do that, I have a little introduction, and I think we'll see a little picture of what AI is not. In some of the pop culture, we've seen it in science fiction movies. We've seen robots that are intelligent, robots that have emotion, bad robots, good robots, robots we'd like to have as a pal, like Jarvis and Iron Man, and those that we really don't want to have as a pal, like Dave in 2001 Space Odyssey. Well, AI is none of this. That does not exist. That's purely the science fiction. Artificial intelligence is an extraordinarily important domain in full expansion, but it's not yet transforming machines into thinking, heart-beating human beings. And that's what we're going to explore with Jean-François today. So Jean-François, before we dive into the AI subject, I'd like to speak about the COVID alert. You are on the Alert COVID-19 committee, who has developed this application that many of you, I'm sure, may have downloaded from it's for the for your intelligent telephone, and it's to be able to track if you are in the vicinity of someone who or been in contact with someone that's had the COVID-19. But Jean-François, many people are quite worried about this and personal and privacy. Tell us about this application and what it does.
For sure. The COVID Alert app is the effort of a lot of people. It's a broad collaboration between Canadians. Really proud to be co-chairing the advisory committee that oversees the development, the functionality, and all the measures that are going around the application itself. This is a very important service. It's an additional tool that we have to fight the pandemic. It's one that everyone can contribute to by downloading the application and using it. In terms of how it works, it's very simple. Essentially, you download the application. The application will be broadcasting an anonymous number that you can't be tracked with. It doesn't track the location you're in or whatever. It just broadcasts a number around you. And if someone else used the COVID Alert app and spend at less than 2 meters more than 15 minutes, it's going to keep the number that you've been broadcasting that is anonymous inside the application. And in a sense, that's it. That's all it does. The magic and how you get alerted is yourself, as you've broadcast anonymous numbers. If for whatever reason you get a positive diagnostic to COVID, we're going to give you a key that allows you to upload your anonymous numbers, no link to your phone, on a server. And every day, everyone that has the app look at the numbers that they've kept track of and they look on the server, was any of these numbers related to a positive test for COVID? If it
And
does, it's going to tell you, and then it's up to you to go and take a test or quarantine yourself. Hopefully, take a test. So it's not necessarily going to be positive, but there's a high risk of you contracting something. So you go take a test, and hopefully you're okay. And if not, then you can protect your family. You can protect other people around you by taking the right measures and making sure that you're healthy, and then you stay distant.
And this is a very important tool, because this is our way, every citizen, to participate in making sure that we are making sure that wherever the virus emerges, that we will let people know, and everybody then will take measure, stay distant, isolate themselves if they have to, go and take a test, do some testing. And with now rapid testing, it's going to be a lot easier to be done. So it's very interesting, but I will repeat the fact that, see, my application is open right now, and I have a green thumb saying that I haven't been close to any number, not someone I know or anything. It's just another person that is using the application that has been diagnosed for COVID. But if I am diagnosed for COVID, then I go in there and I then go and get my key, and they won't know it's me. They don't know where I am, other than they will know this key, and that will alert people to be more careful to get tested.
Exactly.
And this is important. No personal information, there's no privacy, and there's no GPS positioning. So please do
Correct.
use the app. It's a wonderful collaborative work, and we all should be participating if we can. So now onto our subject of today, artificial intelligence. Well, I mentioned in the introduction that you founded 3 companies that use these kinds of techniques to help us solve problems and figure out things in society. So there's 2 questions here. First, how did you get interested into AI? What, 20 years ago, when most people didn't even know the term except in science fiction? And second, can you define the term for us?
I'll start by defining. I'll tell a little bit of my story after. But I like to think of this technology as a new way for people to program software, and and there's a goal here. Me not using AI as an adjective, because we tend to just think that, hey, artificial intelligence, it thinks by itself. Like we suppose that it does a lot of things that it actually does not do. So what it is, it's systems when exposed to different data that can pick up patterns, trends, and can learn from the examples in the data, and then be able to make predictions. And we can apply that to all sorts of environment, all sorts of problems. It is quite powerful. It's been progressing quite a bit. But the thing to remember is that it's very narrow, and it's trained on very specific tasks. Either the task is to understand a sentence, or the task is to count objects in a picture, or the task is to recommend you the next piece of information that is the most relevant based on the habits that you have or the things that you tend to look for, so that you don't have to search for that piece of information. So very, very narrow task. If you take the technology outside of that task, of course, it can't do anything. It breaks down.
Correct. It's a program. It's a
It is.
very sophisticated expert program that does something very specific, but it's often repetitive, computationally complex, that would take a human being a lot of resources and a lot of manpower, and it is able to draw a conclusion for a huge amount of data. But it still is a program which has been programmed by a human being, correct?
So now, I mean, when it gets to my story, the short story is I've always been passionate about the solving problems, and I come from a family of entrepreneurs. So very early on, I got exposed to different business situations, and felt that software could be quite powerful at helping out making decisions in tons of situations. So I've learned to program by myself, And at some point, after building a few,
What language did you start with? Fortran?
C++ was
Yeah,
my first.
you're young.
I know I'm a
Fortran
youngster.
is even like earlier than that, or basic.
And essentially, my passion brought me to look at harder and harder problems. And I, by accident, encounter scheduling problems, which are combinatorial problems that are very, very hard to solve. And I first tried to, use rules and program and, do what we call heuristics, and with like little success. And I really got frustrated. And then I started to look and search, and I encountered actually professors that were teaching a science called operation research that devote their work to solving these kinds of problems using mathematical model. And then my eyes went up, and I was like, wow, this is really cool. I got to learn how to do that. And that's how I got interested, learned from the professors, collaborated with them. I hired them in my first company. And then from there, I didn't stop. So I'm still very passionate about it today.
And now you're at the head of Element AI with Mr. Joshua Bengio,
Correct.
who is one of our worldwide expert in deep learning. I have a question from some of the people who are listening to us on Facebook or YouTube. It comes from Marc-Alexandre Paquet. He's listening on Facebook. He's asking, can you differentiate between AI and machine learning?
So AI is used in a very broad sense. And depending on who you're going to ask to and the kind of definition they're going to give, it is loosely utilized to include techniques like operation research, statistical models, and a lot of techniques
Character
that
recognition.
are, yes, under that big umbrella. Machine learning is a subset of these techniques, and the most popular techniques being deep learning nowadays that are part of the machine learning tool set. So it is a subset of techniques that are under the broader umbrella of artificial intelligence technologies.
I often use the example of the health system. And the health system is this big, 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 all encompassing, where we have all the various departments. And then you have surgery and pediatrics and so on. And that's what it is. I did my master's thesis in natural language understanding. So teaching computer to speak like human beings and understand normal language. But it was at the beginning of the 90s, and we did not use artificial intelligence as a term. It came later, but it's evolved so fast that today we are able to use techniques, programming techniques that are driven from big data sets from artificial intelligence to solve very useful applications. Can you give us a few examples of the kind of things that AI really does?
So very compelling applications are in the world of I mean, there's there in biotechnology. There's tons of applications. We've seen it applied to being able to predict the behavior of molecules inside the human body, the interaction with cells. We're seeing this applied also in genomics to be able to better understand the dynamic that the different parts of the body will have depending on change in the genes and all sorts of things like that. Of course, this is applied also in the broader industry when it gets to supporting business people to make decision around the demand that their product is gonna foresee, or to monitor, for instance, the quality of the production on production line for automobiles, looking at the if there are mistakes on the way things are painted, to detect problems with different parts that are being produced. We've seen it applied to the aluminum sheets and detecting error in the production of aluminum. So AI now is making its way in tons of areas where we have lots of data. We can detect and extract the patterns, and we're able to then make very fast and smart prediction to help people make the right decisions.
And that's the key. It's when the data set is so big that in order to pinpoint tendencies or make conclusion or direct the next course of affair, it would take way too long or it's too complicated to do. But the AI techniques is a tool to help that analysis and then the direct. But it's still nebulous what it does, because I'm having another question. It's coming from Sébastien Bertrand on Facebook. He's saying, how does AI make decision?
So the system is going to make a decision. Like models themselves are going to make predictions. And there's a few examples. If you look at some of the work that has been done around AI models that plays either Go, chess, or the ones that been used at Jeopardy, etc., they give you sometimes some insights in how is the model inner working, how is that constructed, and what you'll see is the model makes a prediction about the best decision to take in a situation, and it's never an absolute one. It's going to be I have 85% confidence that my next move should go to A4 on the board. And then I'm going to predict that if I play A4, my odds of winning are going to be of 15% compared to 12%. So it's all about estimation and prediction. And the way we make decision is by building a system that essentially will pick the best predicted outcomes and will play the game according to that. So that's essentially how most models.
It's a statistical model, and it's refined with more data. The more data, the more the statistical models are refined, and the better output they come out. I mean, speech recognition is exactly that. We are not feeding the computer how to understand words. They don't understand words. They understand zeros and ones. But they understand that if you've got a P, then the chances there's a K right next to it is quite low, but there's an A next to it is higher, and so on and so forth. And we feed an enormous amount of data into those programs to help the decision, and then of course we refine with human beings.
What's fascinating nowadays is that a lot of these very, very large data sets for, let's say, it's general purpose task. Either it's to recognize an image or, let's say, understand a body of text. This is something that can be transferred from one problem to another one. So we now have very, very large corpus of data that are used. You can train what we call generic models on these corpus of data. And then you can use very little amount of data to specialize that model around a specific task. And that's very exciting, what's happening in this field. It's called the field of transfer learning. So where you now can have these models that learn something on a certain data set that can be reapplied in a new environment. And this is an area of research that is quite dynamic, and it's really exciting, the ability that these techniques have and what we can do.
This transfer knowledge is a decision of human being to take that data set conclusion into the other one. Yeah. But I imagine that maybe one day that will be done by a decision that is programmed within the machine itself, which brings me to a bit of a crystal ball question. Right now, AI is it's a program that deals with a lot of data and produces an outcome for very specific application. But what do we see in 20, 50 years from now, or even more? Are we going to have a bit more closer to what the science fiction model?
What we'll see first, and we're starting to see the first hint of that right now, is more and more collaboration between everybody and machine learning system. And by collaboration, I mean that so far, as much as you've all been in touch with artificial intelligence model, like all of you, it's impossible to not be in touch. Either it's your system that recommended a route on a map system for you to
The
go from point A to
voice
point B,
recognition on the phone.
voice recognition on the phone. Either it's the product that got delivered to your door, your phone that recommended this content. Maybe you're watching this stream because it was a recommendation made by an algorithm. There's very little amount of control you have right now, and very little amount of interaction that you have with these models. And this is something that is changing. More and more, what we're going to see is the ability for each user to provide proactive feedback to these models to reach a level of sophistication that they can learn from that feedback and adapt.
To integrate that into then the next phases. So
Yeah.
that we are not just being fed the conclusion of the program, but we are influencing.
Correct. And this is a very important nuance because right now we tend to feel very disempowered by some of the services that are pushed to us. And it's because these systems are being programmed, packaged, and pushed. Where in fact the technology is reaching a point where as users we should be asking to have a high degree of control, not just control over the preferences we have, but literally control over the overall dynamic that this system has. Like meaning that I should be able to decide if I want to optimize for a certain type of content or not, and not solely being observed and be put into an echo chamber because I've watched, let's say, videos of I don't know how to cook something, and it just like keeps feeding me things around food. I should be able to express my intention, my desires, and have that interaction. And this is applied to consumer tech, but of course, what we're going to see is in the business world, from a future of work perspective, we're going to see more and more of the tools you're using at work change, and they're going to become much more collaborative. Your email might be, have recommendation about text or things that you want to say, things you may have forgotten. You're going to receive documents, and AI may help you extract information from these documents collaboratively with you.
Yeah.
So, but that collaboration is really something that's going to pick up. And that's what I'm predicting over the next 10 years. Every day, you're going to be truly working and collaborating with AI.
And again, it'll be a programming tool that will be adaptable a lot more, but it won't be a feeling. So should we be scared that one day a program would take over? Because that's a question that comes a lot. I'm not either.
We shouldn't. Now, I can see why people may do that leap. But seriously, I think from a technology perspective, as I'm talking about that collaboration, this is an area where we have control, and actually we should take control. So, and we're seeing it. Like we're seeing a population and people demanding. And I'm talking here beyond privacy. I'm talking here about being in control of these algorithms, being in control of the systems, being able to fine tune them, and being able to decide to stop using them. As much as I think it brings tons of benefits, it has to be in an environment and in a context where it's healthy. And then therefore, a lot of the situation we have right now, we're lacking options and we're being forced and certain types of utilization. And I don't think that it's necessarily the best for everybody.
It is, but there's still some question. I know you are advising some of our leaders and policymakers, but there's still some question about ethics, the big brother, because we know, and we've talked about it, it takes a lot of data, a lot more data that we could could be able to parse in a little time, and then can look everywhere at the same time using computers and machines. But when it comes to the big brother syndrome, where, say, for example, we know that we have cameras all over cities now, almost in every corner of every street. And is there ethical aspects we should worry about? And will there be a time when we will have to potentially regulate what we do?
I think, and then so you've pointed it. So I've been advising governments and being part of some committee around ethical use of AI, and the emergence of trustworthy AI. One of the things I'll say, and it's one of the main conclusion, which is not so exciting, but very exciting because it's not exciting. And it's the fact that if we just go for transparency, a lot of the laws, a lot of the system, the principles, the ethics that already exist solves a lot of the situation that we're facing. The problem is when things are not transparent. So we talk about the cameras in public and artificial intelligence. It can do a lot of bad things. It can reduce our freedom. It can create all sorts of situations. At the same time, we can also use the same tool to control, limit, and make sure that the benefits that we get from deployed systems are greater than the downside, and that we actually protect freedom, protect people data, protect people privacy. It's all about how we're using things, and it's about transparency. Like, bottom line is, we need to know what runs in these systems. We need to get access to these things, and if we do, you'll see that the Charter of Human Rights, all the things, all the work, the body of work that have been done over the last 100 years plus applies here. And if you just use this, things are going to go okay. But again, we need that transparency. That's the important aspect.
And it opens up a whole slew of professions and field, because it's not just the technology, it's how you use the technology, how you implement it, and how you take it to another level without breaching any of the liberties that we've fought for. But it is true, though, that right now there are things we don't necessarily want to do, either dangerous task or repetitive task or task that would take too long. And these are extraordinary tool, very powerful tool to help us move into a better society. We had a question in the French session that we just had about is this going to evolve, you think, at a point where it's going to like take off on us, that it's not just the algorithm taking over, but the fact that we'll come to a moment of singularity where it'll be unpredictable what will come next?
I think so. I think things that are accelerating. This is true. The concept of singularity is a point in time where things materially change, right? Beyond what would be recognizable by people who would look at it from the past. And that's the concept of singularities. Like, you're getting exponential acceleration in productivity, performance, etc. And then at some point, it accelerates so fast that it's not just incrementally different. It's a phase transition. It's like materially different. And we've lived through some of these kinds of a change in the past. We've been going through that with the advent of internet and having a global network to share information. You go back to the 80s, and it would feel very awkward for someone from the 80s to be suddenly transported in the world we were in. And I think it's going to still be true when it gets to the technology, but I really don't believe that we're going to lose control in the process. Actually, you lose control the moment you give up. And I don't think we should give up at all. Actually, we
And we
should be
won't. I
more
don't.
proactive. So these are tools. They're going to get more powerful again with the right amount of transparency and people staying active and having a voice in the process. I'm very highly confident that the benefit and everything we'll get will vastly overshadow the negatives.
I agree, and it's about critical thinking, which I could be, should be, if it kind of is, but really thought at school, by which you ask yourself questions. It's the same with misinformation. Before you disseminate, technology will evolve, but you don't let it overcome your capacity to reason, capacity to make conclusion, and capacity to say, oh wait, this is not exactly right. I'm going to ask a few questions, and I'm going to go deep down into reliable sources so that I can know the real knowledge, the real truth out there. So there's still a lot to do, but it is a fascinating topic, and one where there's a lot of profession for a lot of interested people. So I'd like to go back because, Monsieur Gagné, can you believe we are already at the end of our conversation? It goes really fast. Um, just to mention again, the really important part of your work has been to be a contributor, a citizen contributor, and being on the COVID alert application committee. I just want to mention it again, how important this application is. We're in a pandemic, and we all have, as citizens, to contribute to the fight against it. And by using this application that has nothing to do with our personal data or privacy, we are contributing. And I thank you for your service to this country, but also for your enthusiasm about a field that is at the same time fascinating, a little mysterious, but truly is actually very down to earth. So thank you very much for accepting to do this conversation, and all the best to you in the future.
Thank you very much. Thank you.
In the meantime, for those of you that are listening, I'd like to put a bit of an advertisement for our next GG conversation next week. It will be done with people out of this world. We will be speaking to 2 astronauts who are currently on board the International Space Station. That's Chris Cassidy, who is finishing a stay of 6 months up there. I flew my second mission in space with Chris Cassidy, so I know him well. And we'll also be speaking to Kate Rubens, who is a microbiologist, and it's particularly interesting. She was the first one to sequence DNA in space, and she will talk to us about pandemic and other aspects of research and the importance of continuing to look for the unknown and the uncharted, and keep our antennas open. Thank you very much for listening. Have a great afternoon. Au revoir.